the interruption.
Okay, the software product lines can be modeled by using feature diagrams, as you already know, and mainly requirement changing time. But feature models are representation that can be changed for a given solution because they are used for modeling solution space, and all the features can be expressed on different positions in hierarchy, and this is dependent on domain analysis and its result. Feature models express what is common and what is differs, as you see in the next part, and we associate solution space elements with problem space elements there. Some tools are available, like gears, view variants, or plugins in Eclipse known as feature ID, where it's possible to compose components in the sense of component as the modular part with exposed interface, and compose the whole application. What is feature? Feature is known as user visible aspect. That means that user can perceive it, can see it. For example, the product removal or something like this. It can be also quality or characteristic of a software system. In another, another definition is logical unit of behavior given by set of requirements, because the user mental model are the main part for modeling variability. Commonality and variability. Here is the example feature diagram. I will briefly explain it in a few minutes. These are features. In the top there is the abstract feature, and you see another features like difficulty or about are the mandatory features or common features. These features are in every product because they are not dependent on any variability part. Here is a difference when we talk about strategy in this game or feature model of a game, because the strategy feature is dependent on computer, which is the variable feature. That means when we not include the computer, the strategy will be not included also. But mainly these common features are spread through all products in product families, and they are enabling to use given features, and mainly represented by as components in different contexts, which helps to reuse these components. Other part are variable components. You see them with this unfilled dot or circle, and for example, player name, statistical challenge, and they can be included or can be removed from final derivation, and so on. We have also alternative groups like difficulty, when user will choose only one difficulty for his game during play. It can be beginner, intermediate, or expert, and so on. It's already no notation. I only explain it. As I said, the component in the native meaning is the modular part with exposed interface and encapsulated functionality. Also sometimes like the whole microservice with isolated dependency using, for example, virtual, and you are using Python and so on, or npm, some other package managers, and so on. The product family is the platform, is a set of component-based subsystem interfaces, and the product line architecture is the architecture based on variability, because the differences between other architectures is focused on variability amongst products in comparison, for example, with the reference architecture. In this example, I will present the application in TypeScript when I developed a family of two maybe distinct products, like a puzzle application and designer application. On the left is the puzzle application, when, as you see, user can play the puzzles, choose a given puzzle and position it in the board. And in the right, bottom right, is designer application, when user can select many, for example, shapes, pictures, and design the cover of this bottle. What I want to show you is the commonality and variability in this application, as common parts which are not seen there are, for example, the functionality for resizing of the whole browser window, which is responsible for calculations of every object on the canvas, to resize it according to aspect ratio, and perform it without deformation and without many user UX problems there. And we reuse these components across also different types of application, like this designer application and so on. But another part is variability. For example, the puzzle should not be deformed, it also may be resized. It can be only moved to drawer when we want to remove it, and so on. Instead, in designer application, we can deform shapes, maybe remove them at all from the application. Also, another types of objects like text and maybe other images are maybe required there, and so on. Here is the feature model of puzzle to play application. It is the product from domain analysis, and we want to configure these features and variability in this application. Now I will explain domain analysis.
Can I ask you a question?
Yes.
These two products are in one software product line or separate product lines?
We try to analyze the quality of software product lines. Now they aren't, but they should, because as I said, they will reuse many existing.
You want to put them together,
components.
So you're constructing a software product line out of these two products.
Types of products, but mainly the produced software product line is based on.
Is it that each one of them is, in a sense, in its own right, a product line? So there's a product line of puzzle applications, because you've shown us
I have created one
a feature model.
so far.
So this is, yeah, you created one application, but essentially you're thinking of a product line of puzzle applications, and there is another product line of design applications, and you want to put them together.
Yes, I don't have a product line for design application at this time, but
You're incorporating.
but I will.
This design application is just one application, while puzzle applications are kind of a product line, and you're integrating.
Yes, I will integrate them
into one product line.
one product line to evaluate
Good.
the benefits and maybe problems of this approach, but another products based on canvas with the same problems can be also built this way. During domain analysis can be limited if you already have a feature model as a compression of user mental models. In this example, I will present my project from last semester when I was using Aspect J and refactored already provided application on GitHub with this feature model, but it has a lot of problems. For example, there was no code reuse, there was no still extensive games, lack of encapsulation of object-oriented principles, and for example, needs dividing of static methods to appropriate classes was required. Business concerns are not fully separated and so on. It was only hard-coded functionality, and we use aspects because they can be removed from code execution, because aspects can intercept points in execution and helps to derive products, and it's good to extend functionality and in various ways. How I said, the additive composition of features, and for example, there is possibility to add voluntary features, choose specific strategy, and so on. Here is for mandatory features we use Java code. For these variant parts or XOR alternative group, we use aspects to model them with possibility to remove them as the modular parts and so on. But the main part of this approach is the configuration of features. As you see, many of them are binary, only two values are possible, true or false, if given feature as optional feature is included or not. But some of them, like difficulty settings, have strings in their configuration, and these features are mapped to feature model, something like this in this game. For example, strategy, associated value, computer strategy in configuration file. Every application should have configuration file, but this is the configuration file for managing variability. And when we do the refactoring, we have encountered some problems. For example, if you know Aspect J, you know that this is the complex language. Point cuts are twice as long. They are repeated parameters there. Maybe if you develop some kind of database system, there is the problem with privilege aspects. They help you to access private fields, but in the end, this granted access can be really disaster for this type of systems. Then they usually need state extension because join points are not available in many cases, like some logging inside method or another operation inside method. And empty methods which are added to object-oriented code are needed, which are known as hooks. they can be cached and by aspects. And there is an ability to create own exception for new aspects, and there is necessary to use dynamic exception and so on. In this project we implemented Cuckoo's Egg. I only explain it because a lot of classes that can be derived from the base class and replace another object-oriented classes can be removed from compilation, and this way the software product line can be modeled and variable features easily removed. But the main part of my presentation is the final product derivation, when we make a transformation from problem space to solution space, and it is meant that we generate some applications from our existing product line. And in this point is necessary to enumerate the many variation types. As you know, there is optional variation where we include or not include given instance, given feature inside a given product or derivation. Or there is possibility to choose one instance from n instances or k instances out of n instances, which are depicted in the picture on the right with this field angle, which represents the OR functionality. And these types of variations should be supported by software product line during derivation to flexibly derive the product in various features. And here is the example how, again, how these variables are mapped to feature model and enables us to preserve feature models in code, because we will construct the feature expression from this code using something like this expression, which can consist of and or operators. As you know, OR operator, one of the features should be true, or derivator should evaluate it as true. For example, feature one should not be included, but we have AND operator on feature 2 and feature 3, and both of them are true, and means that both of them should be true, and this wall and will be evaluated as true, and so on. And when given expression will be true, the part of code should be included in the final product, otherwise not. Or when the derivator finds no such expression, or all expressions will be false, and the resulting file will be not included. Here are designed annotations. The first one is to annotate wall classes. We use streams to process these derivations, and if we annotate the, for example, computer player, as you saw, it's a variable feature. That means when computer opponent is set to true, then this feature will be included, and so on, and we can perform Cuckoo's Egg under it. But the next two types of annotations can be combined together. The first one is to annotate the wall methods, which enable us to include or exclude given method from final product or derivation. And the third one is to annotate imports, because if we remove only given methods, some imports can still remain there, and we need to get rid of them. I want to mention that in some languages which which haven't got the developed or mature aspects, like aspect J, then there are problems which needs to duplicate some parts of code, and they need another type of annotation where we move some these parts of code from aspect part to our derivation, because otherwise we need to make a duplication given part of code. And here is the example using aspect J how to configure the methods. For example, this on the bottom there is the around method and use of cuckoo's egg. Two variables are required, setting player names to true because we set the computer name during the start of the game, and computer should be included, and this means that computer component should be also true, and this method can be included in final derivation if these two conditions are set in configuration file to true, and so on. But the main application and the main benefit from maybe this type of generator is to reach as a high level for use as is possible, and we can generate all of cases of games. In this case, we have 4 binary or optional features, and one case when we select one option from 3, and when we multiply it we get final 48 games or configurations, which can be easily and fastly derived from this type of a game. But this is not the case when we want it, but later I will show it some case when it can be really suitable and beneficial to generate all kinds of games. Now I want to show you the mentioned applications TypeScript. You heard about commonality and variability there, but now I will talk about the requirements given by this type of product, because we develop whole product line and we perform domain analysis based on these type of products, and we reach the point where we decide if aspects should or shouldn't be included finally in final derivations. And because of immature aspects, they will exclude aspects from final derivations at all, because they slow down our application, and they not produce as modular parts as is maybe necessary, and that affects the whole application, which is not as manageable as it should be. But what is the main point to construct software product line from TypeScript and maybe single page application is that it should provide high UX, and developer should have a possibility to develop high UX application. It depends on given application, of course, but without such maybe functionality as known elements, material design, reactive forms, which shows incorrectness, on routing, and maybe lazy loading and so on. The user will maybe struggle with our application, and it will lags and so on. Also, it should be accessible from everywhere, because this application can run from browser, and it's performing one application, and no backend is necessary, because everything is compiled is running in our browser. Then it should be possible to easily evolve our software product line and possibility to evolve product derivation, because when we get rid of aspects, usually developers not know about aspects, and they can develop given derivation in their own cycles and so on. And as I mentioned, we use proof solutions like those for resizing the canvas with the raw window, and maybe some other customization of libraries are possible with mentioned approach. But here, as I said, aspects are used only for the main part, for aspect-oriented software product lines or software product line in general, and this is the feature management. And finally, we get rid of these aspects. As I said, some tools are in nature in JavaScript, and a lot of scientific articles try to compare these tools using given metrics. The first one is invasiveness. It's expressed how well aspects are separated from the rest of the code. For example, aspect J, there are no such problems because we can produce the aspects as classes which can be fully separated from code, but in some languages like TypeScript, there is a possibility to put or not put some aspects in compile time, and should be provided during the start of application or so on. Then
is this rather obliviousness, that invasiveness? I mean, we want aspects. They are invasive because they invade our code, but the problem is that code should not be kind of aware of aspects, or you should not be forced to put there are some hooks for aspects, or some like points to indicate some labels or prepare something.
Maybe yes, but there is another problem. That, for example, there is the language Lara, which is not based on JavaScript but is used in JavaScript, and this language can be used using, for example, in this application, and this is the third-party language which can be used with different languages, not only TypeScript, and these files are fully separated from the code and can be weaved during the compile time, using compile time weaving, what can be beneficial. But in literature it's called invasiveness, but maybe yes, they are part of obliviousness, because we should specify the aspects in code and how they are connected. As you will see,
maybe you do not notice at the moment, but I think it's good to look at whether this particular paper mentions obliviousness at all, because as we learned, there's strong tendency to ignore past work in the field, and simply maybe they did not come across this notion, and this is a very old notion from the beginning of aspect orientation, but it was strongly emphasized. So it's if they did not mention this, then when you refer to that work, you should really kind of criticize this.
yes,
and compare this. So that's an opportunity to re-establish things. But anyway, good, very good. Thank you.
Okay, thanks. The second one is briefness. It expresses how easily and exactly and without complications possible to use given method. For example, as you saw, writing point counts in aspect J, they are twice as long. Some repeating parameters are there when we specify what should be done during execution, and some arguments which should be used in our around methods and so on. Then the third one is maturity, which specifies all abilities and possibilities of the whole functionality provided by given library. And the most mature tool is Aspect J, but this tool is available in Java, and in this case it means special compiler, which not positively affects the application written in this language, and so on. In TypeScript, a lot of tools have different level of these restrictions, and many of them or all of them are based on proxies which slow down the application, which is managed somehow, but for me it's not good solution, and maybe because the code is affected by aspects from third place, and there is hard to manage it. The process in this application consists of 3 steps. The first one is separating aspects from business logic. The second one is to annotate variable parts and provide business logic, of course. And third one is derive requested product in software product line with no aspects at all. And as I mentioned, we propose the fourth annotation because we need to move some code parts from the aspects to final product code, because aspects will be fully removed from our application. And here is the example. Firstly, we need to create in Angular the service when we specify all of features with associated method, which should be called to introduce aspects or start affecting code by aspects, and given service which helps us to access the variables of this service inside the code method. And finally, we parse the configuration file because it should be separated from the application, and in this recursion we check if given variables for features are set, if features should be enabled or not, and then call given method by using call construct on method reference with the reference of the given method of given service. And the service is specified here in call, and we provide another configuration extracted from the whole file, only part which is required for a given feature. To configure it further inside code, and what is necessary is to connect this aspect of feature management with whole business logic, usually in app component, is the main component in the Angular application, where we inject this as dependency injection. This only one line of code connects the whole parts, and as you saw later, we can remove it easily. Here is the aspect example. As I show, here is the configuration of selection K features, jigsaw, anti-jigsaw in puzzle to play application out of many features. And Here is the aspect definition, there are defined logic. It's implementation of two-consec pattern. I won't bother you with details, and in the end I call AOP by using two AOP library to catch the call of constructor or maybe method, because there is a problem to catch call of constructor in TypeScript or JavaScript at all, and we need to catch the method and in round return the new object, which is also returned in the given native constructor in business code, and overrides the object which is not correct, and force us to fully think about aspects removal at all. But I think later maybe some another libraries which can only catch constructor and replace the whole call will be in future available, and so on. I forgot to mention, I said something about the Lara, which is not using JavaScript at all, and it supports full invasiveness, but this language is not suitable for TypeScript because it works with code representation, JavaScript code representation using trees, and the TypeScript code should be compiled to JavaScript and so on, and the management of the whole functionality should be really complex to use this tool, and maybe impossible. And this is the business logic, only for reference. You should not see any aspects there or any related code.
I started to lose track a bit with the previous slide.
Yes.
This is
this is the book.
This is the configurator.
This is the method which introduced aspects in fuzzy in the game
yes.
configuration service.
Yes, I'm confused by mix. These if statements are configuring statements.
Oh yes, they are for configuration file.
According to features.
If jigsaw algorithm is included,
then this is applied. If
this is
applied. Anti-jigsaw, then the previous one. It seems that this aspect definition is interleaved with its configuration.
This is all the configuration. It's all specification of aspect because it's all hook and method which should be applied by using round.
So you do not have, as in the previous example with those battleships, you had an external configurator according to the feature model.
By using aspects.
So here you don't have any external configurator. So aspects are configuring themselves. According to the
yes, because there is no possibility to remove them from compilation at all, but they should be included during runtime, because many of them are applied as proxies. They are called as proxy. Okay, and in the second step, we annotate this functionality. This is the only one point where we should get rid of tree manager service, which is introducing feature management, and this is also required to have one annotation which result positively, because if none of features result with a positive value, then the whole file will be removed, or this not a case or intended behavior, because we want this file, this component in our application, but only without this injected tree manager service. And also we not annotate with any annotation all aspect services which are separated in separated folder and so on. Maybe another example using expression and some table, because to this point we configure the code only, but in Angular there is possibility to include the given components in template, and for this we use only the HTML attributes like feature selector, where we specify the selector of given component, and derivator if this expression specified in features attribute will be true. For example, feature zoom will be set to true. Then derivator replace app zoom menu selector to div element, otherwise it will remove all div element from this template. By using, you already know, beautiful solve in Python probably. If you are web scrapers, in Java is something like this. And what is necessary? Necessary is to annotate the whole class zoom menu component, because if we don't want it, we should remove the whole file at all. And also there is dependency in ng module, given module, where the given component is included, and it should be also annotated by a line annotation, and during derivation it will be included or not included, and so on. As you see, there is a requirement to affect multiple places on code, but we preserve feature modules and the configuration of these feature modules there, mainly here, and the product and every annotation. But another example is making gallery variable. I will briefly explain it. We should annotate the gallery component, because if we don't want it, it should be removed. And also, as you saw, we need to annotate the imports and the import of a given component in declaration of ng module. And then we annotate mock data, because here we only want to include game component when user hit some URL inside his browser or follow a given link, and we need to add or remove the whole configuration from the list of possible routes or configuration of routes in Angular. Okay, and the third step is only start the product derivation, because we already set required parts, and now we can get the product with or without each gallery according configuration in our configuration file. And now I want to talk about the evaluation, how I proved that my software product line is really beneficial in these types of applications. As you see, we can evaluate variability and commonality by using structure variability coefficient and structure similarity coefficient. I provide the example from my test case when I test that it works during the analysis of my application. But now I want to say something about structure similarity coefficient. Is the ratio given by number, as you see, cardinality number of common components, but the components in their sense as the modular paths, which are not dependent on another components. They have also exposed interfaces and communicate only through these interfaces and so on. And this is divided into the whole components, also common ones and variable ones. and this number is explaining how well we use components across our software product line, because common components are components which are included in every derivation, and tools are used in different contexts, and we talk about different products in different product families and so on. This we should have it high, but it's mutually conditional with the second structure variability coefficient, which is also important to have it. We should have it also high, because it explains the variability, and its ratio of number of variable components divided into number of all components, the common and variable, and it specifies how many variable parts are in application, and thus our software product line is more economic, because we can provide functionality for many customers and their mental models. But in my application or application in TypeScript, we not work with components in their native sense as encapsulated and modular units at all. But in Angular, you already know that Angular is really modular, but not as much modular as we need in this case. And as you see from this test case, we have 3 variable components there, and 2 variability points, B and G, which can or which should be included, or maybe we not include them at all. And all of other features are variable. Then we make this assumption, and then the whole evaluation, we assume this, and we can use imports to another components to count number of these components and so on, and is implemented by using stats, and it prevents duplicities and so on. Then it should be the correct, but as I said, it's only the assumption. Another variability measures are decoupling and stroke coupling. Decoupling is a real problem in software product lines, because if we have decoupling, it means that 2 or more variability points guard the condition of given of another 2 or more variables guard condition for another variability point. That means that we need 2 different variables to specify if given feature should or should not be included, and so on. And it introduced the problems. This is a division of big coupling variability points divided into number of variability points. In our case, we have introduced the configuration of variables in our expression, and I think this can be also count in our application, because they are already provided in code by variables are already provided in code by using expressions. And the second one is the strong coupling, which is subtraction of independent variability points divided into number of variability points. We subtract it from 1, because if we only talk about this ratio, it says to us how many independent variability points are in our application divided into number of variability points. It has the positive meaning, because we want independent variability points that have no dependence with others and so on. But this strong coupling coefficient describes the problem when the components are strongly coupled, and that means the value of one variability point affects another, and it makes constraints and problems during development. And mainly how to measure reuse. We have the metrics which can be used to measure reuse for the whole software product line. The first one is the most beneficial when we generate all of possible derivations from our software product line, and maybe in the sense of architecture, when we not only focus, as I focus, on low-level variability inside the given code of programming language, but to compose whole components written in many languages and so on, which is also possible with my approach, but is maybe it's low variability and so on. And this component reuse rate is a ratio with the sum of number of components which are included in given derivation. It's sum because we count all derivation which contain given component, and then we divide it by all possible derivations of members of software product line. We don't use it because in application TypeScript we don't have all derivated examples and so on. It's still in development. The second one is a reuse benefit rate, where it's possible to make implication how much given component affects reusability, and it's sum of the whole components associated maybe with the encapsulated part of the whole module, or in our case it's the whole variability part of our software application, and this sum is divided into the sum of the cost of the whole, all components in our software product line. And there we can count additive value. I have it in this slide, where we can say how much given variability points affects the whole product line. The cost of our product line here is 8,000 and something under it, and we divide it by cost the whole variation points, as you see there, and this is the numbers how each component affects reusability. And
can you interpret these values in terms of using aspects, or what's the intention here? You're assessing your product line?
Because when we introduce some variability points, we need to count as much in comparison to all components, the given variability point and given functionality, how much it supports reuse, introducing this variability point.
Yes, I understand that, yes, but I don't understand how is this related to you. What are you evaluating? What are you assessing? Are you trying to? I would expect you to assess whether your approach to maintaining aspects is feasible, or does it introduce any additional cost or whatever when you're using these metrics, I don't know, or whatever you use to assess it. This seems as if you're assessing your quality of your product line in absolute terms. Like, is it good or not, but you're not assessing your approach. How does your approach affect the quality of a product line?
The main approach is assessed by different metrics, as you can saw from previous slides. I can return to them. They are related to using aspects at all, its invasiveness, maturity and briefness. And invasiveness is reached by separating the part of feature management from the business scope.
Okay, I understand this, but these further metrics that you use to assess a product line, it seems you did not use them to assess how your approach affects these matrices, to say so. So like how it would be in a kind of a common case, as with a common product line, with not applying your approach, and how it would be with your...
Yes, but I not found any metrics, and these are metrics for use, applied on software product lines. But in comparison, maybe in other approaches, this can help to assess the variability point in this way, because we have separated aspects and we count included components and maybe count lines of code in them and so on. But I not found any, because it's normal software product line, only without aspects, with annotated parts. Maybe generate some components.
So
and then
you want to say that you arrived at, with your approach, you arrived at a product line that is not bad, to say so, like this?
yes.
This is the intention.
And how we can assume
Okay,
the value of components and so on.
Yeah.
Yes, maybe the possible evaluations are then another evaluations are possible when we derive given products, and we can analyze the other components in comparison with it. But my approach has derivator and the all functionality to produce derivation, and I think it can be accessed as another parts in terms of reuse. Maybe.
Okay, I think I understand now the intention behind using this assessment. So your product line is not, as I said, not bad. So you using your approach, you arrived at something that is could be considered as a kind of normal or like usable product line.
Yes, and here are the given metrics for structure, similarity coefficient and structure variability coefficient, which are both of them relatively high. 42% is the reuse of the assets across the product family members, where all family members contains given services and so on. I think this is beneficial to introduce Angular software product line, because 42% of code is included in every derivation. And the second coefficient, the variable, is also high, up to 60%, with 40 variable components in some, and we are only introducing this software product line to further evaluate it. Then I think it's good, but it depends on number of variability points and so on. And here is the sum of the reuse benefit rate with given coefficient. For example, TypeScript code, number of lines are multiplied by factor of 3. Template code is some number of lines of template codes is multiplied by factor of 2, and number of code for styles like CSS, SASS, and SCSS are multiplied by factor 1 divided by 4. And now I want to show you my last application, where is the most beneficial to use to generate all of the samples. It's application on fractals, and it can be written also in aspect J and shown on canvas and so on. In the background you see the modified back curve fractal. But what is the case? The case, we have the fractal domain containing a lot of types of fractals or families of fractals, and then we try to derive some products. We get fractal derivation, and then we can validate it. And it is not easier task, because we need to derive all of samples and provide them to users, for example, and this process should be as fast as possible, and then we can value some attributes there related to given personality of user and so on, like aesthetic feeling from given fractals, because many of them are constructed they see as it's only the chaos. Where you can't distinct the given elements, but some of them are really interesting. And software product lines and maybe feature models applied on them can we can benefit from them, because on every variability point we can say what we are generating, and from this mathematical model we can produce the large data set with maybe hundreds of variable features. It depends how much variability points we will introduce in our example. It needs the best product derivator or the best design, and there is the question how to catch all feature variability, because this domain is focused on aesthetic perception, and if there is a suitable feature diagram, because as I said, this feature diagram can differ, and if only mathematical model is possible or something else should play a role there, which affects the whole functionality of our application. And here are some types of fractals. Here are only small changes related to size of circles. When we compare them together, maybe number of iterations during generation. These fractals can be generated by using recursion or as the string replacement, and in the string we specified when to perform, when create a line, or when to move to different direction and rotate and so on. And it can be written on few lines of code. Here is another example of Krishna anklet, and here is the modification here and here, where we add another circle between two lines, between connections of them, or replacing the wall shape to another. A lot of types of fractal exist. In the bottom you can see Sierpinski triangle. On the left is the Koch snowflake. In the bottom there is a back curve. It's known due to these curves in double E. And on the right is known Krishna anklet from previous examples. That's all for me. If you have questions, you can ask. I provided a few literature there. Maybe I have another examples from few applications, maybe the papers, and maybe some other diagrams of performing derivation of products, like dynamic ones or structure ones, like class diagram or sequence diagram. And finally, I have also diagram for quality checker when I implemented functionality to observe the variability points and by using recursion, count number of components and evaluate the variability, and finally usability of given components. Okay, thanks.
Thank you for the lecture, but you said you can take some questions. So,
Yes,
any
yes.
questions? I asked many questions, so I'm not going to continue with this. No questions. Come on, just one small question. Okay. Okay. Thank you once more.